Thank you so much for joining us today. I'm gonna wait 30 seconds, a minute, for those that are a bit late comers before I start. So bear with us a second. Okay, I can see the numbers are going up, so we'll make a start. My name is Matteo Rovati. Thank you for joining us today. I'm a consulting manager at BSI, and I lead our Connected and Automated Mobility Standard Program that is supported by CICA, the Center for Connected and Automated Vehicles. For those that are not familiar with our work in the CAM sector, our program has now entered its 7th year. So we've been working with industry for quite a while, and it has produced 12 standards covering a range of topics from operational safety cases to human factors in remote operations, from ODD taxonomies to methods for identifying the minimal risk maneuvers. It has also informed several international standards and other industry activities. So we feel it's been contributing positively to the development of the CAM industry in the UK and globally. We've been running these knowledge sharing events regularly since the beginning of this program. Last year, we debunked some of the myths surrounding self-driving technologies together with some experts and industry stakeholders. And we also discussed what are the on-road applications that are spearheading adoption of autonomy in the road environment. Today, we want to broaden that discussion from road to other realms of application of autonomy in the transport sector, of course, such as maritime and aviation. Engaging with regulators and industry in the past few months, we've come to realize that all domains are experiencing some of the same challenges. And that's the reason why we want to understand, with the help of experts, how those learnings and those challenges can be discussed and shared, and perhaps how standards can help in identifying solutions to them. So before we begin the discussion, just a bit of a housekeeping. You'll see some guidance on screen. If you have any questions for the speakers, please send them using the question button on the GoToWebinar app. I cannot promise that we will address all of them, but I will try and weave in some of those questions in the conversation. At the end of the event, you will also be able to access the recording, and you will also be able to request a CPD certificate for attending. I'm now pleased to introduce Professor Siddhartha Kasgir, who has kindly agreed to open the webinar with an overview of WMG's work on cross-domain autonomy and the role of standards. Siddhartha is one of the most active contributors to our CAM program and to transport standardization, both nationally and internationally. He is head of autonomy at WMG, and he's also the director of PAVE UK. Welcome, Siddhartha. The floor is yours.
Thank you so much, Matteo. Thank you for the very kind introduction, and also thank you to you and BSI for the invitation to this webinar. It's an absolute honor to be here, partially because it's a topic of huge personal interest to me and quite close to my heart. So I'm looking forward to the conversations during the course of this webinar. So what I'm going to talk today about is the work that we've been doing in the UK in terms of translating learnings from one transport domain to other transport domain when it comes to autonomy. And it's a journey that we started a few years back. Some might say we started it almost a decade ago. And I'd like to talk to you about what we've learned over the past decade, because 2025, 2026 are going to be pivotal years when it comes to autonomy in the UK, not just for road autonomy, but other transport modes also. So back in 2022, we brought together the stakeholders across the transport modes from aviation, maritime, and road autonomy to explore, and it's initially just an exploration, to explore if there was an opportunity for the different transport domains to work to learn from each other, not work together. I think work together would be a bit too much of an ask in the first place, was to learn from each other in terms of when it comes to ensuring safety of autonomous systems in their each of the transport domains. So one of the foundational principles that we had for those conversations is this concept of not reinventing the wheel. And those of you who know me would know that I like to do things in multiples of three. So the way we were approaching this whole conversation when we brought into the same room road, aviation, and maritime autonomy stakeholders was to evolve, develop, and validate. So when you talk about evolution, we're not trying to, as I said, reinvent the wheel, but we're trying to see what already exists and how we can actually expand and extrapolate from what already exists, and then develop on top of that, and then use the stakeholder ecosystem to validate the concepts that we are developing. So the three pivotal years, well, if I say so, in the UK's autonomy journey, I would say would be 2014, 2022, and 2023. And these are some of them are quite personal to me, and some of them I would say are very, very strategic for the UK. So 2014, some of you who are in the road autonomy space, in the connected autonomous vehicle space, would know that 2014 was when the very initial UK automated driving trials started with the UK Auto Drive project and the Gateway trials. So that was a pivotal year for the UK when we said, okay, let's jump onto the bandwagon of autonomy without knowing we will actually realize true autonomy and in what time frame. So so to me, 2014 was quite pivotal. And over the course of the next 6 to 8 years, what happened was a lot of development in the road autonomy space. And the whole program that Matteo had mentioned that was supported by the UK Centre for Connected Autonomous Vehicles supported the standardization activities in the space of road autonomy from 2014 onwards. And during that time is when we realized, especially at WMG, but then speaking to our stakeholders in the aviation and maritime ecosystem, that a lot of the learnings that we had made in the road autonomy space could be translated into aviation and maritime. So 2022 was when we brought these stakeholders together into the same room. And some of them said, it's the first time I'm speaking to an aviation person. And when in 2022 we brought them, they saw the benefit of speaking with each other. And then the course of the next 1 year, we had regular conversations and workshops with these stakeholders in the same room across the three domains that led us to creating this cross-domain safety assurance report, which had some key recommendations. I won't go into the details of the recommendations itself. What I wanted to focus here was that this document, which was contributed to by 38 organizations, both from the UK and internationally, laid down certain opportunities, both for the UK and the wider autonomy ecosystem, to actually realize safe automated driving systems, but also drones and autonomous ships. And you can access the report and the details of the report over the link that you see in front of you. But one of the key identification aspects of this report, which was also new to me, and it only came through the conversations with these stakeholders across the world and across the domains, was this concept of safety. So as a safety engineer, and I've been working in the automotive space for the last 15 years, we used to think of safety in a very binary aspect of safety means engineering safety. As engineers, we need to look into how do we prove that a system is safe. And these conversations with the three different domains actually led us to this conclusion that there are two pillars to safety. And one pillar is what we call as establishing the safety level or engineering safety. And the other pillar is about communicating safety. And that is equally, if not more important than the engineering safety aspect. And that is one of the key findings that came through these conversations. And always, if we go into the details of the engineering aspects, there are a lot more, but I wanted to provide you with a high level overview of where we were. So there was a lot of benefits that we saw in terms of from a philosophical level at learning from each other, and I'll give you a very concrete example of what we have achieved actually as a benefit, as a consequence of this philosophy. But the other thing I wanted to highlight, and the title of the webinar has been very aptly created by BSI is this learnings from cross-domain and the role of standards. So I'm trying to give you two different approaches towards this, and then bring the two worlds together of cross-domain learnings and the role of standards. So when it comes to role of standards, I again like to think of things in multiples of three. So the first one is enable, second is establish, and the third is stop. When it comes to standards, I believe, and it's a very concrete and a very strong belief, and that's the reason I spend a lot of time in standardization, is the concept that standards should enable innovation. Almost everybody would accept that. They should also establish best practice. Almost everybody would accept that also. But the third one is equally important that we don't focus on a lot, and it's even more important for emerging technologies like autonomy. Standards should also enable us to stop unsafe introduction of technology. And this is a very key aspect. So standards are supposed to enable, establish, and stop. Enable innovation, establish best practice, and stop unsafe introduction. So if you think of the learnings from cross-domain and the role of standards, how do we bring the two together in terms of a concrete work that as engineers, but also as policymakers and regulators we can use? And I'll give you a very concrete example now. So how do we realize this dream? It's very nice to say, oh, you can learn from each other, but what does it mean actually? What should I learn, and what would be a concrete example? So as I mentioned, in the initial space from 2014 to 2020, 2022, the road domain had done a lot of work around safety assurance and introduced this concept of operational design domain, which essentially means defining the operating conditions of your autonomous system. And BSI played a leading role in this activity by actually preempting what the world would need. So in 2021, BSI released the PAS 1883, which got updated into PAS 1880, another version in 2025, which provides a taxonomy for autonomous for operational design domain. And that was the work that we did in the road autonomy space. And through these bringing the stakeholders together, the aviation people saw, oh, this is a very interesting concept, and this would also help us in the drones world. So BSI and the aviation stakeholders, Future Flight program, worked together to create an aviation ODD taxonomy as a consequence, and a direct learning from what we did in the road autonomy space. And that's not it. In parallel, the International Maritime Organization has been developing the MAS code, which is the regulation that would govern autonomous shipping. And they saw this concept of operational design domain being so foundational to autonomous systems in road domain. And they said, oh, we should actually also incorporate this in our MAS code. And we are now talking regulation. We're not even talking standards. So the regulation that is being worked on right now, and the non-voluntary text would be ready for 2026, is directly referencing operational design domain, which was developed in the road domain back in 2014, 2015. So what I'm trying to demonstrate here is that it's not just a philosophy of cross-domain learnings, it's a concrete example of work done and leadership by BSI in the space of road autonomy through operational design domain taxonomy, which got converted to ISO also, that translated into work in aviation, and now is being translated into work in maritime. So not just the regulation, but now there's also new work item standard being discussed at the ISO level for maritime autonomy for ODD taxonomy. So this is a concrete example of how you can benefit and how we have benefit in the UK and demonstrated UK leadership through this space of learning between different transport modes. But the last thing I would like to say before I hand back to Matteo, while I absolutely appreciate BSI for all the support and enablement that they have provided us, behind every standard actually is a group of people. Standards, the success of standards and the creation of standards is down to experts and the contribution of experts. And BSI is here to provide the supporting infrastructure, but it's the experts who create. So it's a very, very people thing. And the success of standards going forward will also depend on people. and the people's contribution, their time, their effort, their expertise in the creation of these standards. So please, if you are listening and you would like to explore how you could contribute to a world of safe autonomy, please do reach out to any of the speakers on this webinar or to BSI, because we need you. And I think BSI needs you, because they can only provide the infrastructure, but we as experts have to provide the content and these standards. And that brings me almost to the end. If you want to hear a bit more about the report itself, I've put a link into on the slide. I think the slides would be shared with you after the webinar. And I'm very much looking forward to the panel discussion with a very illustrious set of friends as well as experts. So I'll hand back to Matteo for opening up the panel session.
Thank you, Siddhartha. Yeah, thank you very much for introducing and setting the scene so well, but also for the call of action, which I obviously fully endorse. And we'll paste the link that you've just posted also in the chat, so people can access that directly. There are a lot of things that you brought out in the presentation that I'm sure we'll walk through with the rest of the panel. But before we do that, I want to introduce the panelists. So I'll ask them to turn on their cameras if that's okay. I've asked all of you in advance to think about introducing yourself by telling us one of the crucial benefits and one of the big challenges of deploying automated systems in your domain of expertise. Obviously, Siddhartha has already brought some out, but I was keen to hear from each of you. So we'll start with Dr. Paola Palade, who is the AI expert at Jaguar Land Rover. Hi, Paola.
Hi, good afternoon, everyone. It's a pleasure to be here with you today on this panel. Thank you, Siddhartha, for a very good and interesting introduction to the topic. So as Matteo said, my name is Dr. Paola Palade. I work in Jaguar Land Rover, and my expertise lies into AI ethics and AI ethical issues raised by the introduction of AI in automated vehicles. So my primary domain is road transport, and the major challenge in road transport in deploying autonomy on the road is effectively the complexity and the unpredictability of the real world environment. And Siddhartha made reference to the operational design domain and the challenges that we have with that. We also have a high degree of human behavior variability, unstructured objects. It's very complex, I would say. But on top of that, I really want to emphasize that another challenge is the societal acceptance and the trust that the introduction of these vehicles needs to bring with itself. I think until we don't have a high degree of societal acceptance and trust for the introduction of AI in automated vehicles, it will be very hard to achieve that deployment and to realize the benefits that the technology can bring with itself. And those benefits are obviously we can reduce the human error, therefore we can reduce the fatalities, but also we can make transport more greener, more safer, and much more accessible for everyone. So the benefits are huge, but until we don't have public acceptance and the technical development to remove some of that complexity, those are the points that I wanted to make. Thank you.
Thank you so much. I'll move on to Vicky Murdy, who is the Future Flight Innovation Lead at UKRI. Obviously, quite a different domain of application. What do you think are the benefits and the challenges? Is there anything in common with what Paola's brought on?
Yes, I definitely recognise some similar challenges there, but I'm going to pick up some different ones. I dare say we may go back to some of what Paul has talked about when we're having more conversation as we go through the panel. But yeah, so in the aviation domain, I'm going to start with the challenge and then I'm going to go with the benefit afterwards. So in the aviation domain, I think the biggest challenge we face really is regulation. So the regulation that will enable these autonomous vehicles to safely integrate in the skies with existing aircraft, because we've got to fit in with that existing ecosystem. So similar to some of the challenge there that Paola's talking about on the land, where we have a lot of different actors. It's a complex situation. We've got an extra dimension up there in the sky. So we do have the similar sort of challenges with that. In terms of the benefit for us, really, it's the benefit to really scale. So we've got drones that exist today that are doing jobs, and we've got eVTOLs that are being designed. So these are small passenger carrying aircraft that are currently in sort of demonstration phase, but we're getting towards commercial reality. Now, in order to scale those, being able to really connect people where we want to, autonomy plays a big role because it really impacts the economics of it. But then the societal trust element that Paola talked about also comes in. But yeah, for us in aviation, autonomy is really about enabling much bigger scale to bring benefits to people through these technologies.
Thank you, Vicky. I'll move on to Tony. Tony Boylan is a principal specialist in the assurance of autonomy at Lloyd's Register. What are the key opportunities and also the key challenges for the maritime sector in your view, Tony?
Hey, good afternoon, everyone. Thanks for that. Just to explain, I am the principal assurance of autonomy at Lloyd's Register. We're a sort of 270-year-old classification society. In essence, arguably one of the oldest safety organisations in the world. And for those not used to maritime, in essence, we are a technical provider to both industry and the regulators. So we sit between the two and support in both directions. Yeah, I mean, there are a number of drivers. As I said, as a personal mild frustration, I was the desk officer who launched autonomy for the Royal Navy in February 2005. The pace for that demand is now coming on across multiple navies for rather obvious reasons. So there's a real uptake and urgency now starting to appear in that domain. But when we go to the other side of the spectrum, the commercial world, again, there are multiple different drivers, multiple different needs, and it is a complete spectrum of maritime. And as a lot of people can guess, there's a lot of traffic in maritime. And when we have problems in the Suez, financial hit across the globe is significant. So that just shows the impact that maritime has. But particularly if you look at nations such as South Korea and Japan, the aging population there is even more accelerated than the UK. So they have significant urgency to bring autonomy in to sort of help sustain their capability early next decade. In Europe, there's a slightly different drivers, but we're not too far behind those curves. And again, UK interests, for instance, is a lot. And sorry, the complexity. This is slightly outside the mass code, which is more aimed at the cargo vessels for now. But in time, everything we develop that will cascade down and be applied to this certification, which is sub 24 meters, where we have a lot of interest in supporting wind farms offshore and all those other sort of survey capabilities. So the needs are broad and many, but fairly coherent and common issues and complexities across all domains.
Thank you, Tony. Siddhartha, I'll look back to you. Is there anything that you want to add in terms of challenges? You already explored a bit, the one that you've probably already worked on, but anything you want to add?
Yeah, I think I'll pick up on a point that Vicky raised in terms of regulation. And I think it's very important in this emerging space to understand the interplay between regulation and standards and the role that standards can play in enabling the implementation of regulation. Because I think those of us who are involved in the regulatory world across each of the domains would appreciate that there's not too much engineering specificities that can go into a regulation. And that's where the standards come in. So I think the role of BSI and the BSI committees and also ISO is very important in that space to actually help the implementation of this high-level regulation in each of the domains, because the concept of regulation and philosophy of regulation is the same across each domains.
Thank you so much. Okay, the way I've been thinking about structuring the rest of this conversation, I want to start, and I'll pick up on some of the questions that we've received in advance of the webinar from attendees. I want to start with setting a bit more sort of the challenges and the sort of some of the common threads and themes, and then move on to learnings and transfer. Siddhartha has already preempted both of them, but keen on drilling a bit deeper in both. So one of the themes that has come out from many questions that we received from attendees, and sort of links with what Tony brought up when he mentioned the aging population and sort of some of the challenges related to that in specific geographies, but globally really, and is how autonomy is changing the role of the human operators, whether it's a driver, a pilot, or a captain. What do you think are the sort of the legal, but also the public trust barriers, because that's also something that links with the changing in population composition, to removing the human operator or to replacing the human operator. Yeah, which are the sort of the key barriers or the key challenges in your view? Who wants to start?
I'll go first.
Yeah, Vicky,
Somebody's got to, haven't they? And I'm sure we'll end up with different things coming in from different angles. So I think in the aviation context, at the moment, we have people who are already sort of remotely operating drones. So when I say drones, I'm talking about the flying ones. Sorry, I should say UAS, but drones is just so much easier to say. So I'm going to say drones in this conversation. But when I talk about it, I'm talking about flying ones. So yeah, so we've already got people who are remotely operating drones at the moment, and by that I mean non-passenger carrying vehicles. So these are vehicles that are carrying out services or delivering goods, but not carrying passengers. So at the moment we're shifting from, you know, that sort of, there's a lot to look at towards how do you actually scale some of that, because at the moment you've got to, even if something's operating autonomously or you are directly flying it remotely, you're on a one-to-one. You are supervising it one-to-one. So actually looking at how we can unlock multiple simultaneous operations of somebody either, somebody supervising multiple vehicles that are operating autonomously at the same time. I think that's really important for the drone side. And when we talk about I mentioned about eVTOLs earlier on, one of the fundamental underpinning concepts of the economic models for those aircraft is that they will get to a point where they are autonomously operated, but those are carrying passengers. Some of the airframes might be used for carrying cargo, but they are designed generally to be carrying passengers, and therefore that whole human trust thing comes in really significantly when we start talking about that. So some of the technology there is actually capable today of flying without a pilot on board, but humanly we are not ready for passenger carrying aircraft to be flying without a human pilot on board. So there's a real challenge there for the industry of how do we move through that? How do we move through those stages of the sort of the technology being demonstrated to be safe, and the public acceptance coming along of people then understanding what these technologies are and understanding that they are safe as they then go through those different phases. But yeah, so there's a real public trust journey to be gone on, and I think Paola had already sort of mentioned similarly in the land domain. So yeah, so that's a bit of a starter opening on some of that question from the aviation point of view. You're on mute, unfortunately, Matteo.
Whoops, sorry. Thank you, Vicky. Any other inputs from other perspectives?
Yeah, I'm slightly happy to jump in there. Noting we both use sort of dynamics. Yours is aero, mine's hydro. It's sort of they're both pushing fluids around. Is very similar sort of, and again, this is where the importance is to exploit the overlaps and identify that, because, for instance, we use lots of remote operating centres specifically, commonly for the small survey things. But again, we are going to start looking at international trade. So it's how we deploy those. How are they federated? All these different dynamics. How do you do interpersonal relationships of responsibilities within an ROC? How do you transfer those skills ROC to ROC? For us, is how do you serve from the vessel or platform to the ROC and vice versa. So all of those dynamics, cognitive loads, and all these sort of secondary things come in. So there's plenty of areas where touching base, so to speak, with other domains, say, what's your experience, what's your learnings, how do you brigade, how do you shape the approach to that? Are you ahead of the sort of curve, so to speak? You've gone through that pain to go, actually that approach or wasn't quite sort of or it was end life, so to speak, and actually it's better to go sort of this direction. All those sort of learnings are very, very useful. And I mean, obviously, we're all exposed to the data and operational design domain, and we're all looking to sort of exploit and take that forward. But again, into maritime, and I'll warm the conversation up straight sort of earlier in the conference, so to speak, is we're looking to sort of drive in quite hard is the human element and the operational envelope. So the is inside the vessel, ODD is the extra area, but it's trying to drive those and a little bit of it's commonly unique to maritime, and with aviation, I'm sure is commonly unique in other ways. There's significant overlap. It's the sum of the parts, and strengthening those, but where we must be independent, we should go and explicitly not be forced too closely together.
Thank you, Tony. Paula, do you want to bring? Yeah.
Yes, I would like to make some points as well. So absolutely, I think one of the key challenges in removing the human operator is that legal and regulatory framework. We don't have any accepted framework of removing the human responsibility at the moment when it comes to driving. And we are not even ready technically to do so, really, if you think about it, because with cars, you have the complexity of everyone being exposed to that environment in terms of, if you have an automated vehicle driving down the road, you might have your child stepping into the road. So any error, any mishap can really cause huge implications in terms of not only safety, but human acceptance, trust, and all those elements we talked before. So liability also, it's unresolved. That's a huge problem as well. Now, there is work that is starting to emerge on the regulatory framework. So we have at UNECE, which is the major regulatory body, we have now a new informal working group that is looking at the AI introduction in vehicles, which is great. And some of that work already starting to point back to standards. And this is where it's fantastic to already have some of those standards developed and emerging in the road domain, so in road vehicles. And that's great. However, there is also the added complexity that some of these regulatory frameworks are contradicting themselves or pushing against themselves. So we have the big regulatory body, which is the UNECE, Working Party 29, which creates all the major regulations we need to comply with. But also we have now the EU AI Act. And the EU AI Act will speak about having this human oversight, right? Whereas if we want to have automated vehicles on the road, we cannot have that that human oversight. We need to rely on the vehicle being able to make decisions in its operational design domain without a person necessarily overwriting the decisions of that system. So that's where we need to make sure that those two different approaches come together. But what's great from both these approaches, so the work that's happening at sector-specific regulations from UNECE, but also sector agnostic, like the EU AI Act, is that both point to standards independently and to different standards, but that reference back into standards, I think, is very important and crucial.
Thank you. Siddhartha, so you went off mute. So.
Yeah, maybe very briefly before I hand over to Vicky. I know she's urging on. I think one important thing I wanted to highlight was the fact that while we'll have all these frameworks ready, both the standards and the regulation, ultimately there's a person in an authority who has to approve these systems, and the skill set of that authority also needs to be brought up to speed, because these are new technologies, and most authorities, not only in the UK but also worldwide, are not skilled enough right now to be able to approve them, even if you have all these standards and regulations. So there's a lot of work that the authorities have to do to upskill their workforce to be able to ask the intelligent questions when a developer comes to them. Vicky.
Yes, thank you. No, that's a really good point. With the thing I was going to come in on was some of what Paola was talking about there, around, we mentioned about legislation. So one of the challenges is what's the definition across these different domains of what the sort of driver or pilot, or I'm not sure what the marine equivalent is. Actually, is it
master?
Master. Yep, sorry, master. So master, pilot, or driver. What are their responsibilities? So we commissioned some work by the Law Commission to look at aviation, autonomy in aviation, and they've done one consultation paper, the second one closed recently. So they're still writing up all the findings from that, but they're trying to look at, are there actually primary bits or secondary bits of legislation that needs changing? So things like the definition of what a pilot is, and what they need to do. Actually, it does give us the opportunity for that role of pilot being somebody that is not necessarily physically on board. I don't think that was a particular barrier that was found in the work, but actually there are a lot of responsibilities legally for what a pilot does when we're talking about passenger carrying vehicles. In aviation, we already have a very extensive set of what a pilot does. Now, if that pilot's not actually physically present because it's somebody that's remotely doing it, or supervising an autonomous system, then who carries out some of those different roles? There's all sorts of things that came out of the Law Commission work. So I'll pop a link into Matteo to put into the chat for anyone who does want to read up on that. But yeah, I think understanding actually what are the legal sides of all of these different technologies in terms of the person in control, ultimately what their responsibilities are, and does any of that need to change when you move to having those people not necessarily physically present where the vehicle is. So I think that's a real key area that each sector will have slightly different challenges in, but it's a common challenge.
Thank you, Vicky. I'm going to pick up on that point of sort of remote operations and human supervision that both you and Paula have brought on to ask you the second questions, which is sort of what is the role of all these external or all the external infrastructure that would enable some of those elements of connectivity, communication networks, digital maps, satellite communication. Let's look at it broadly, and what is the readiness level? Because obviously, it feels like we're all seeing that as one of the key enablers of both the sort of the public trust element, but also the sort of the legal enabler for autonomy. So, where do you think we are in that sense in terms of readiness? Who wants to jump in first?
I'll start that. If I don't mind, just going back to the last point again, the slight difference is if we take it to a very simplistic level, a driver, singleton, a pilot, two normally in the crew, so to speak. If you come to maritime, you've got the bridge crew, you've got the engine room crew. There's multiple sort of potentially 18 sort of in a fairly, should we say, average size crew, all with core roles that can contribute. Well, not nearly all, but a lot of them can contribute to navigation and stuff like that. So the different elements in approaches between domains. And I came from, as I said, defence, trying to prove the technology, trying to drive autonomy into defence, and saying that here's the technology. I haven't seen a lot of technology move. It's obviously matured in different ways, and the next iteration, generation. But the principles of technologies haven't moved a long way over the last 20 years. Primarily, there may be a few nuggets, but primarily it hasn't moved. So I like to sort of take it as a little bit simple. It's more actually the explainability and evidential base of this, because some of the challenges, and they said the mass code has just come through with the IMO. It is in draft format, but it's a very strategic goal-based document. And for anyone adopting that, there could be 101 ways you try and explain the system. And therefore, when we get towards the regulatory end of it, it is very complex and challenging for anyone to have the confidence to push it through. So standards and all that, and commonality of approach will help massively in that. But as noting we're coming up to the silly season of Christmas, something I also like to do, a very old UK sort of comedy classic from a Christmas special, I think it's even 1970 something, is Morecambe and Wise. And if you look at it, I won't explain it, all the right notes, and it's Andre Parvin, the world's most famous probably conductor of an orchestra, and it's how an orchestra is shambolic. But if you imagine what an orchestra is and how, if you get it right, it all comes together, that's the way, in very simplistic terms, I see autonomy. I think technically we are largely there. There's elements to work on, don't get me wrong, and it can be improved, but we are largely there. It's how you put the case together and how you make it all work together. That's the challenge still to be sort of delivered.
Thank you, Tony.
So I think just coming back, I fully agree with what Tony mentioned, but just coming back to the point, Matteo, you were mentioning around remote operation. I think that's an interesting area, because in a sense, it actually brings more synergies across the board between the three domains. Because one of the key issues in the road and aviation and maritime, if you say differences initially, is you don't have a trained operator in road, you tend to have a trained operator in aviation and maritime. When it comes to remote operation, you expect that remote operator to be trained across, irrespective of it being road, aviation, and maritime. So I think from a situation awareness perspective, from a training perspective, from a qualification perspective, we see even more synergies between the three modes of transport when it comes to remote operation. However, I would like to highlight that the fact remote operation doesn't in itself mean remote driving or remote controlling an aviation or a vessel. So when we talk about remote operation, it's very important to understand the nuances and the differences of remote operation between assistance, intervention, monitoring, and control. So I think that's where I see, again, a huge role to play from a standards perspective. I know there's a lot of work that is initiated at ISO level on the road domain and now also in the maritime domain, and RPAS, or the remotely piloted aviation aspects is already very mature. So I think that's an area where I see a lot more synergies happening in the course of next months and years to come.
Thank you, Siddhartha. Vicky, anything to? Oh, Paula, do you want to say anything? Yeah.
Yes, you also asked about infrastructure. So I'm not very familiar with how developed the infrastructure is in the other domains, but definitely in road, it's a high degree of unevenness. So infrastructure has a lot of maturity to do in terms of making sure it's even and we can rely on the infrastructure. And again, the role of standards there is very important when it comes to connectivity. So V2X connectivity, vehicle to anything. The same for smart traffic infrastructure. So we would rely a lot on the infrastructure, and that's very key in enabling autonomy. Obviously, AI is a key enabler as well, because we rely on it for perception and fusing all the data from the different cameras and LiDAR and sensors that we have on a vehicle together to do that path planning, prediction, and also that ethical decision making. So those are the key enablers, I would say, for us to have that. But infrastructure is one of the major ones as well. Thank you.
Sorry, and just a very quick one to clarify. As I said, I do think a lot of technologies, whether it be LiDAR, whatever it may be you're using, and there's obviously radars are going to be a key one for maritime. Comms, the growth in satellite capability and bandwidth availability and affordability, most importantly, is because obviously maritime used to go, should we say, dark for a lot of spaces because it was very bandwidth constrained on prohibitive cost. That's game changer is going to open up a lot for autonomy for rather obvious reasons.
Yeah, and I was going to follow on and sort of say, yeah, definitely connectivity is hugely important for the aviation context as an enabler. We really need to have redundancy of different comm systems, and there's increasing usage of trying to use mobile networks for drones, but the mobile networks aren't necessarily designed with that purpose in intent. And obviously when you start going to different altitudes and things, and particularly when we get to if we're looking at eVTOLs, then it's trying to find what's the right solution for the right kind of vehicle, because eVTOLs will fly at a higher altitude than drones will. So maybe the mobile network is the right solution as a primary for drones, but then you need backup. Do you need satellite communications? Do you need radio? Do you need all the different sort of options you have? And then for eVTOL, it's perhaps more like traditional aviation technologies that they would use for communication. But the challenge is there that we really need that that integrity of communication, because you're relying on it for command and control rather than just purely as a means of communicating between humans. So it becomes much more important. So yes, connectivity and communication is really, really important for that sector. And the ability to sort of have that redundancy, and then as we said about systems underneath that, if we're creating autonomous systems in a safety critical role, those need to be explainable systems. So that explainability of the, particularly if we've got things like AI in use there, explainability of the AI and the autonomous system and how it's making those decisions, that's a really key thing in aviation as that context moves forward. I think we've started to touch a little bit on actual infrastructure as well. So the infrastructure that supports that comms network is clearly important, but it's not the only bit of infrastructure that's needed in the aviation context. In order to actually know where all the other aircraft are, that's a major challenge, because you've got to know that in order to be able to integrate safely. And a lot of flying is done today at certain altitudes where that's visual. That's a pilot looking out and seeing things. Well, that doesn't work if you haven't got a pilot on board. So, how we solve that challenge, and how we try and help the rest of aviation to be electronically conspicuous and with ground beacons and things necessary to back up that, to transmit signals and back up with different, again, redundancies of different types of information, that if something's not reliable, there's another alternative. that's really important as an enabler for us in aviation. We need to have that infrastructure there to support those autonomous systems being able to operate safely alongside others.
So I might just jump on that. I think Vicky raised an important point around redundancy and aspects, and I think that actually highlights the difference also between toy use cases or toy developments and actually commercial deployment. So it's what we have learned over the course of on all the three domains over the course of last 15 years. It's very easy to do an experimental demonstration, and it's multitude of a magnitude harder to actually do a commercial deployment for the same technology itself. So let's not get, when we see autonomy, it's important to not get tied away by technological demonstrations. They have their place, they are important, but it's the commercial deployment which requires the kinds of things that Vicky has mentioned in terms of redundancy and resilience also.
Yeah, I will just say one thing. In the aviation context, it's not always easy to even get the demonstrations happening, because actually even being able to demonstrate these things has a lot of regulatory challenge in itself in order to make sure that it's safe. So as we try and demonstrate things not operating in isolation, but operating in the same airspace as other aircraft, there's a lot of work the Civil Aviation Authority are doing to try and help demonstration projects actually start to do that, because that's the real key that you need to unlock to get that commercial activity then happening.
And sort of tagging on to that, do you have any suggestions or recommendation on how regulators in your specific domain of expertise should address these potential gaps and challenges to facilitate the scale up? So is there any learning coming perhaps from one domain that could be brought into the others to facilitate that sort of scale up of activities that you can think of?
Was that a question back to me?
To you or anyone else who wants to pick it up? Yeah.
Yeah, I mean, I must admit, I don't know where the other regulators are versus the aviation ones in that context. But yeah, we've used a lot of, I think there's some crossover actually between what's going on in the marine world, maritime world, as to what there is in aviation, of using sort of sandbox environments to try and, identify safe places where you can do some of that exploratory work, sort of test sites where you have some additional protections in place that mean that there's some isolation, and it's only the actors that you want in that situation that are doing things. So scaling that, taking those sort of sandboxy type activities and then starting to broaden the envelope of them further and further. That's certainly what we're seeing people trying to do in the aviation context, and I believe it's similar in maritime. Is that correct, Tony?
Certain countries are more interested in sandboxes than others, but yes, I mean, they are starting to be exploited, and there is value. It's like anything, there is always value in just hands-on and experiencing and lessons learned, and there's a feedback loop from any direction. So to totally believe that, but it is the proportionality, explainability. We can all play the buzzwords of what we have to achieve, and I've sort of sat with a customer before who said, I've done X months of sea trials, it's gone really well, and then you break that down slightly to say, okay, if we take a simple crossing event, the most simple thing you can get in maritime is just 2 vessels, we'll add a third to make it slightly more complicated, then add some offsets, different speeds of 3 vessels, change the sea states through different few levels, and then say add in all the faults and failures potential on that type of vessel. You went from 1 crossing iteration to 13.7 billion. And it's like, okay, now we have to demonstrate where we can say and there's methods that we all know, there's methods of rationalizing and stuff like that. But when the customer then appreciated, actually, okay, perhaps a few months of demonstration is challenging. And when we're talking about things even perhaps more expensive than aviation, even, which isn't going to be cheap to get in the air at the same time. For instance, if we want 2 very large gas carriers operating together, they're a substantial cost per day to sail. The very expensive assets in the maritime. That's sort of in the physical world a huge challenge. However, the physical world can still add value feeding back into what we learn. But it is about that completeness, traceability and explainability we've got to get to, because that's where the regulatory space, I think in all domains, is challenging. Even in CAV, we've all seen, and we all look on slight envy of the time and expense that's got in trying to mature those capabilities. But the regulators are still largely sat on it because of the question of the explainability and traceability of everything. But that's the nub of where we've got to. And the more we can share, the more commonly we can exploit each other's skills and learnings, the better we'll be.
Go on, Paula. Go on.
Please, Siddhartha, after you.
No, after you. Go for it.
Okay, so I wanted to say that whilst in those domains, it's very interesting to hear those perspectives for road transport. I want viewers to appreciate the fact that different regulatory landscapes can provide different opportunities for testing. So I think there is a lot of pressure on the regulatory bodies in automotive to provide that framework where we can safely deploy automated vehicles. To give an example, in the States, in certain states, such as Arizona and so on, different licenses have been given to different companies to trial automated vehicles, which in some cases ended up to very unfortunate circumstances with pedestrians being killed or other road users being put in a very high degree of danger. So there is a lot to go to say about open road testing and the safety and the privacy and the acceptance of that, because I'm pretty sure that those pedestrians or vulnerable road users in those scenarios didn't sign up to be part of those trials or put their life in danger in those instances. So I think there is a lot of pressure on the regulatory bodies to actually create that AI governance framework when it comes to the AI introduction. With the introduction of AI in automated vehicles, and we rely heavily on simulation, hardware in the loop, vehicle in the loop, different degrees of simulation before we put those vehicles on the road to do that open road testing. And even when we do the open road testing, we rely on things such as geofencing or safety drivers. So there are different degrees of safety that you can rely on. And I think another different aspect that road can offer to the other domains is the fact that we do interact with the general public. So I think that's where that human interaction and the ethical elements and trust and acceptability are more commonly seen with the road sector and more explored, I would say. Thank you.
So I think the interesting thing here, for diverse reasons, we get driven to the same sort of need and behaviour, so to speak, is maritime doesn't have some of the drivers that you just exposed there. However, the challenges of the availability, the numbers of vessels compared to clearly sort of cars, the repetitious nature of roads, fairly, should we say, static, and I know the trees and the roundabouts and whatever you use as part of that. The maritime's a lot more dynamic than that and stuff like that. So. But we also have a quirk of a different, that we have a UN body, the International Maritime Organization, who owns the mass code. So we have a international body, which is slightly different from cars, where it's very obviously regional based, sort of national based sort of approach. So there are structures that we benefit from that are similar but different and unique, but they all drive to the same sort of thing. Is actually, we're going to have to get to the space of a lot of simulation to support the physical world, because we can't get to it for other means and reasons.
Dr. were you about to add something?
Yeah, I was going to say.
Oh, no, Vicky.
Sorry, picking up on what Paola was saying about, that the fact that actually, in the road context, she's somewhat further along the journey than we are in aviation, and particularly when talked about, sort of eVTOLs and that journey of public trust and acceptance of, moving to a point where there's not a pilot on board when you're passenger carrying. We've got a very long journey to go, I think, to get there. I think the technology will be there. In fact, some of the technology's there today. It just needs further testing and proving out. But actually, they can fly these vehicles autonomously already. Whereas I think there's a real opportunity as the road domain has gone through some of that already with some of their trials, and having things like having the safety driver on board. We can effectively, we're going to, some of the operations, that's perhaps the first step once we go from having fully crewed where the workload is lighter than in a traditional aircraft, but going with it being crewed. So then actually you've got somebody on board who is acting as a safety pilot. They are there in case they need to intervene rather than actually actively doing things, but actually looking at the learnings and seeing how that's been done in the road context and then taking that into the aviation context. I think that's an area that over the next few years needs to develop further, because there's real opportunity to share that learning and understand that. And then similarly, there will be opportunities in the maritime side as well. I think the other opportunity that I really see is that we're talking everything in a civilian context. And I know Tony touched on the Navy earlier on, but I think we also need to try and look at where is the understanding of how do you use these technologies in different environments, and where are things being used the most already? So where can we learn from what was successful and what was less successful, and things like all the sort of human factors elements? How can we learn that from where they're being used the most already? And I do think for things like drones, there's perhaps actually quite a lot of context from the military use, where they are being used in greater numbers than they have been in the civilian context. Is there learning that could be shared that comes from one sector effectively to the other within the same domain? Because I do think that we shouldn't be looking at these things in silos. We should be looking at where are the opportunities to learn and have best practice so that we can do the safest, most efficient job and actually bring these technologies to the point of the benefit for people in the UK.
Thanks, Vicky. And that's a really nice segue to one of the questions that I received from the audience. So I want to bring that up to you. The question is, which technical areas do we see as the greatest opportunity for cross-domain standards in particular? So learnings, but focusing perhaps on what can be done on standards rather than on regulation or other aspects. So obviously we've already mentioned the ODD taxonomy as one of the areas where perhaps there are common threads. We've mentioned perhaps the role of remote operations and the training for operators. Anything to sort of support these points, or any other areas that you can think of that where the learnings would be could be crystallized through standards?
I'll start with.
I think, okay, go on.
Sorry. See whose hands up. I'll start with, and I try and take it. Let's start with the simple things first, almost, and then go. But it's always been a little bit of being my bonnet, and it's where the next generation, dare I belittle the next generation, but their mentalities and their approach and their flightiness, shall we say. I've been 25 years in maritime autonomy. They are likely to be more dynamic and go cross-sector to different roles, and that has risks. Where we're talking about, and obviously there's ODD, but taxonomies and just the language of what we term everything. And if we can get into domain taxonomies rather than just domain specific, because a spade and a shovel, commonly conflated, for instance, but if we get to domains, let's move on an epoch, 10 years epoch, when all these domains are more mature, that someone transitions from aviation to maritime, whatever it may be, but they're intrinsically been working for 4 years with a shovel in their head and stuff like that. And then we talk about a shovel in maritime, but it's subtly different because we mean a spade and they mean a shovel, and it's that. But you are transferring risk, albeit at a simplistic level, but it's an unknown yet. But if we can all get to that commonality where, as much as where it must, it's different, where it can be common. And I think all domain will have its natural. We've all evolved, and maritime's obviously been going a bit longer than others. But so we've got that history of entrenchment of what we call everything. Are there opportunities? And as I said, personally, I believe the country that steps up and says, how do we look at these holistically as a systems of systems solution, and then start mapping it out that way rather than standalone sort of domains, has both a commercial but a technical opportunity and safety opportunity to add value.
Thank you, Tony. Siddhartha.
Yeah, so I think to be very specific to your question, I think anything from a process perspective is where I can see opportunities for standardization. So, for example, activities that are already initiated in terms of how do you do scenario generation in maritime, and what can it learn from the standards we already have in scenario generation for autonomous vehicles for road domain. So anything that when it comes to a process standard, that's where I see the quicker and more immediate benefits from cross-domain learning. So be it functional safety, be it SOTIF, be it scenario generation, be it training of remote operators, be it a methodology for requirements elicitation. All these process-oriented standards is where we see cross-domain synergies, because from our experience, especially in the doing the cross-domain work, once you get to the very specific level of the domain, then each domain has its own specificities. So for example, the concept of ODD is same across each domain, but the ODD taxonomy is very different in each of the domains because of the specificities of the domain itself. So when it comes to process, absolutely, process-oriented standards would be very similar, and the functional requirements specificities would be customized to the domain itself.
It's probably worth having in. Oh, no, you go, Paula.
I agree with what Siddhartha said, and we've seen some successful cross-sector transfers of knowledge when it comes to safety case methodologies and other things like that. So I think that's where we definitely can collaborate today on some of those things. It's Vicky.
Yeah, I was just going to add, when we developed the aviation ODD taxonomy, we did actually look at we looked at the starting point of taking the one that exists for road. So looking at that and going, what was the same that we could keep and be common with, and where were there things that we have that's different because of our context in our domain, and environmentally there were some differences. For example, there were definitely some key differences where we needed to add things in that weren't in there. But wherever possible, we maintain that commonality. Now, that only works if people are doing it in that sensible, structured way of trying to look at what already exists. So actually being aware of what already exists and being connected to other people, understanding what work's going on, that sort of bringing communities together is really important. So that's why it's been really nice actually having the cross-domain work that Siddhartha's been talking about, where we all kind of know each other and go, oh, actually, if I need to find out something, I can reach out to this person. We can try and find what's in that domain, and we can compare and contrast. Because I think, yeah, trying not to reinvent the wheel, trying not to do anything that is, having that harmonization across things wherever possible is really important. And actually, we'll start to see in the future that you could see that you'd have autonomous vehicles of different types, perhaps operating in concert with each other. So, for example, you talk about looking at inspection of offshore wind turbines. Go and do some of that by drone, but taking off from and landing onto an autonomous ship and connecting with that autonomous ship. That's a real genuine use case. I've actually seen people, trying to look and develop things around that. So you can see there are times when those different autonomous vehicles will actually potentially interact with each other. So having that commonality of approach of how the humans that do things and the systems do things, having that commonality wherever possible is really helpful, because it helps people move, but it also helps, as you say, Tony, avoiding those sort of Swiss cheese model moments where things line up because different people have different, and everything stacks up, and then suddenly you have a safety problem.
So yeah, just coming in, and I mean, I've just authored a very large proposal being open. Lloyd's Register are partnered with National Physical Laboratory, and I was in Siddhartha's office only last week, and we're working closely with Warwick on operational design domain for the maritime. So that all these elements coming together. So I've written it multiple times, but one of the last documents I put forward was how to review the actual full assurance framework, and that overtly looks at multiple domains of existing sort of standards and approaches. I will openly say I do not believe maritime can sort of take the burden that Fres and aviation has. So we will be operating at a different level and a different shape. We have to be sort of commercially sort of astute as well. I mean, it's getting that optimum balance of the two. But overtly in that proposal, it looks at 178C, 26262, 4600. It looks at multiple, sort of suggesting these are the documents we will go and standards we will go and look at, and models, and say, actually, for one, yeah, adopt that 100% because it's perfect. Or actually, part of Annex 3 is really useful. Just that one tabular flow is really good, and therefore not reproduce and just stack standard on standard and have three common things that you have to reformat for the next one just to make the next step of the process work. No, it's how do we rationalize and commonalize But where it's done before, if it has value and it meets the needs, why reinvent a wheel? Plagiarism is great in my world, as long as it's of value and used and perhaps referenced. Plagiarism is the way to go, because it's done. Someone has invested the time and the effort. If it functions and it does what it needs to, the chances are you shouldn't go again and do something different.
I would rather use the word learning than plagiarism, but yes, okay.
You know me on Andre Siddhartha.
Thank you, Tony. I have a question coming in from the audience that is domain agnostic, but I'm going to direct it to Paula. Is AI-based autonomy potentially endangering rule-based autonomy? What's your view? And then if anyone else has got views, happy for them to jump in.
Okay, so I'm not sure if I fully understand the question, but I'll give two different perspectives. So by rule-based, if it means traditional algorithms, the way we design them, AI has the potential to make it much more effective and much more scalable and deployable across different scenarios that would not be able to predict or design for. However, there is a degree of explainability of the AI and trustworthiness that comes with that, and the system performance. So that trade-off is often discussed in regulatory and standardization meetings around the ability of the AI to explain itself, let's say in a neural network, versus the system performance. So if that's what the question means, then that would be my answer to that. If it means the rules of the road, potentially, as another interpretation of that, then I think deploying AI into automated vehicles, I believe that the rules of the road could be reconsidered in terms of enabling that full deployment and the full societal benefits that we spoke about that. And in some work that we did for the European Commission, we proposed why that would be the case, with the argument that the rules of the road are not the end in themselves, but safety is. And if automated vehicles can have a higher degree of safety, therefore the rules of the road might need to change to enable that autonomy to be fully deployed. So hopefully that answered both perspectives of the question. Thank you.
I might just add one thing to this. I think one thing that we've realized over the course, especially over the course of the last 3 years, is you can't preempt what the tech would, how the tech would unfold, and we need to ensure that we are able to cater to the needs of the ecosystem. And I think that's where I might pull in a plug for something BSI has done very nicely in terms of what we call as rapid standardization. So the whole Flex program that BSI has introduced is quite useful to be able to keep up with the pace of change of the technology itself. So yes, there's end-to-end AI that's being used, and 4 or 5 years back, people thought nobody would jump on that bandwagon. And now, as far as I know, almost every organization, be it a developer or an OEM, has an R&D program around end-to-end AI. So I think it's very important to appreciate the fact that technology will evolve, and standardization and regulation need to come up with the mechanisms to be able to keep up to speed with that. And I think credit to BSI to be able to do this through the Flex program.
Another point is one thing I'm sort of driving, and we're quite passionate about in Lloyd's, is proportionality and scalability to a project rather than a generic answer. And whatever we do, whatever process or standard we apply, if we just end up coming out with a common template, probably isn't optimal for any party. And the other part is to realise that obviously there's a long stakeholder chain in the exploitation or delivery, however you want to term it, of autonomy. If any single stakeholder or any part of that chain snaps, the chain breaks, and therefore no one actually managed to exploit, whether it be a regulator, term to exploit is to have the confidence to sort of support, class to service industry, the owner operator to get what it is, the OEM to service his contract into all of the, if any one singular thing fails, we all fail. So it's that sum of stuff, but it's that proportionality and applicability, and it's all these buzzwords, but it's focusing in on that to make sure that however we do regulatory or standards application, they're all adding value.
Might come in on something on that as well. Just
yeah,
one of the challenges we have in aviation is a challenge around scale. So particularly in the drone sector, less so in the eVTOL sector. There are a number of companies trying to develop eVTOLs, but it's a much smaller number than the number of companies trying to operate drones. And actually, we have a real challenge with the way that regulations were sort of structured previously was from the point of view of, well, you tell us, you operator, tell the CAA why what you're doing is safe. So it does give you the freedom to be quite individual and bespoke about stuff. But alongside that, the challenge came then that actually for the regulators to be able to determine whether something that somebody was doing was safe or not means they've got to spend a lot of time looking in a lot of detail. There was not a lot of repeatability. So actually now drone regulations moving to more of a standardized, I think it's SORA, which I'm going to try and remember what it stands for. I think Standardized Operational Risk Assessment, but looking at it in a more of a framework way, where actually there are some things that are fairly similar and consistent, that that two people doing the same thing in the same way would come out with the same explanation of their risk and how it's safe and can put mitigations in to reduce those risks. So actually trying to look at what you can in a standard way in aviation is quite important, because the sheer number of people trying to go and use these technologies, and I'm talking fairly generically there about things to do with drone regulation. When it comes to the autonomy piece in there and AI and everything else, then yes, we need to have ways of people being able to explain what they're doing, but where people are doing things consistently, to be able to explain it consistently, so that there's not this constant need for deep, intense review of everything to understand what it's even trying to do, because that puts a real massive burden on the regulator. And it slows things down for everyone, because it just creates a massive bottleneck for them, and that's frustrating for all parties. So yeah, trying to not, as Tony says, it's not trying to be overly prescriptive about everything and solving everything, but actually in the aviation context, we do need quite a lot of standardization of how people do things.
So, and I'm in exactly the same position. I feel exactly the same. Is the way I term it is every project is being commonly unique. And it's the same thing of the approaches can't sometimes not that far apart, but fundamentally different in presentation, and everything goes. So everyone gets more risk averse, to be honest, and the more and more challenging, more cost burden, more and more time delay. So it's not just about being a blocker. It's actually if we can find the processes that facilitates everyone, it's safer, it's cheaper, and it's faster, and more explainable. Everyone wins in that chain that I was talking about earlier.
And I think just one more thing that we haven't spoken a lot about as of now is the fact that the larger your supply chain for your ecosystem, the more the importance of standardization. And if you really want to have a strong supply chain for a particular domain, you need to have strong standards. Otherwise, you won't, as Vicky was talking, you won't be able to talk to each other in terms of, and the concept of interoperability will not exist. So I'll give you a very, very concrete example from the road domain. When we started off back in 2014, 2015 timescales, there weren't many standards when it came to autonomy. BSI, the CCAP program that was funded for BSI wasn't yet initiated. So there weren't any standards in this space. As a result, everybody was doing their own thing. And as a consequence of the program now, everybody is one step further in terms of talking the same language, from when it be the terms, be it the safety cases, be it the ODDs. So I think that's where as your supply chain matures, the standards need to also play a role in helping the supply chain mature.
And sorry to poke in again, but that's explicitly where the challenge we've got now in maritime, where the mass coding at the moment is focused on some of it's not the total domain, but it's a core part of the commercial world. But that's very much a draft strategic document, goal-based, and it still has a lot of ambiguity about how you evidence and provide that. So the more standardization that comes in, even if worst case you end up with multiple standards in the same area, but if you say the class decides to place out to industry and what their needs are, if they adopt a left or a right sort of choice of standard, at least there's a template that's being followed. It makes it more understandable, more affordable for the quicker for us to service, quicker to get to the regulators, to give the advisory to them and explainability to them. So it all comes back to the similar sort of argument.
Thank you, Tony. I seem to sort of understand while you all talk that one of the sort of key takeaways could be that, in a way, the sort of the mismatch that we mentioned originally between the importance of trials and sandboxes in identifying some of the technologies and then learning from them, but also then the sort of how there would maybe some limitations in the scale up of these technologies that comes in between the sort of the trial and sandbox phase and the commercialization phase, can be bridged through standards as a way of sort of making ways of approaching certain elements from sort of terminology down to operational practices common and standardized, so that it makes scalability across supply chain and operations easier. So my question here, it's a long preamble, but I'll get to the question now, is are we doing enough from the standards point of view to enable that, and what could be the priorities that as a national standards body we should be addressing, and where maybe the international standardization forum is a better place for this? Any take on this question?
I might start off on this. I think two key points I wanted to mention. Firstly, I think in any emerging area like autonomy, I think it's very important to underpin standards with some research evidence, or directly, even better, from field learning. So when you're initially doing a standard in this space, it's a best educated guess between these experts in the field. Now that guess might be the right guess, or it may be something that needs to be updated based on what you've learned from real world deployment. So it's very important to have the humility to be able to accept that we need to update these standards as we learn more from real world deployments, because there's no substitute from real world learning. There's none out there. So you can do as much simulation as you want. You will learn a lot more from real world deployments. So that's the first thing I wanted to mention. So being able to update standards, but at the same time, you should not wait till if you have everything in real world to create the standard. So there needs to be iteration, and the Flex program is great. Second one is, it's very when you do that, follow that process, it's very quickly that you will realize that certain aspects are absolutely tailor-made for international standardization. And I think what we have learned from the CAV space, and now also from the marine space, it's better to go into an international conversation with a proposal rather than a blank sheet of paper and say, hello, we think XYZ needs to be standardized, let's put our heads together. It's always useful to actually have some sort of, even a straw man proposal and going into the international standard, because people find it easier to critique and comment on a straw man than on a white blank sheet of paper. And that's where the role of the national standardization body comes in, to help create that straw man that could be used for going into international standards.
Thank you. Any other points of view on this?
Yeah, just jumping on one example, for instance, that just popped his way when you first said that, is human factors rather than the human elements. Let's split those as linked but two subtly different elements. I shouldn't say elements. Two areas is human factors. People know how to measure bodies. Whether we use the US standard, and I said I'm an ergonomic freak. I'm in the 98th percentile, and nothing fits me, and that's why I've never bothered about fashion, because I just can't find any clothes to fit. I've accepted that at 50 years old. I've just learned to live with it. But is the human element, when we start talking about cognitive load and the specificity of what that means in remote operating centres for autonomous systems, and again, we have to be careful to say there might be 3 subsets of that for different, someone needs to look at that in the appropriate detail. But to create more standardisation in that, to what we mean about the cognitive load, how a team within an ROC interoperate, how they transfer skills to or transfer command, really, should we say, to another ROC. What are the implications? What are the nuance of that? And I think this has been some good work, don't get me wrong, and aviation has a lot of experience in certain elements of it, but I don't think anyone stood at that high level and really looked at those specificity and the nuances of what we mean there. We've got some very good generic things, and just say a seat is a seat. We know what percentiles we're trying to meet. Job done. So you can actually measure the desk, the screens, whatever it is. That's pretty much standardized, and we know that. But the other elements, I think, are still open to sort of some solid work there to help bound that well, because when you go to remote operating centers, that they're all again commonly unique. They're all trying to sort of achieve the same game and aim, but is they all approach it in subtly different reasons. And what's the rationale behind that? What's the requirement for why they've done it that way? And that explainability, traceability, and evidence to have confidence in the solution is perhaps absent, and that's not helped by the absence of a standardized approach.
Yeah, I'll come in on that as well. I totally agree. I mean, in aviation, we have a long-standing history of what we call human factors. I'm not sure if we're coming up with the same terminology. So who knows? Maybe there's different terminologies. But in terms of like how the human decision-making process and how people affect safety. So human factors, massive sort of safety topic in aviation. Got a lot of experience about that. But that's with today's technologies, or yesterday's technologies. Not about what's coming of all the different kinds of how we interact with these new technologies. So I think there's a lot to be done, as I say, around multiple simultaneous operation, or there's anything that's where you're not physically a pilot on board an aircraft. The human factors of everything to do with that, I think there's a massive area that we need to look at, and I see that as we say, there'll be things that are different in your setup of, the cognitive load of the role will depend on quite how much responsibility you have, how many different variables you might have, but there will be a lot of commonality across the different domains for somebody who's in that position. There'll be a certain amount of commonality, and then there'll be subtle differences within it. But I think it's a big thing in the aviation sector that I don't think we actually understand internationally. This is, in fact, it was mentioned at ICAO had a first advanced air mobility symposium, summit last year, and actually that was something that people were talking about there, was that we've got these technologies coming along that mean that people are doing things in a different way, that actually that human and machine sort of interface bit, the human factors around all of that, is an area of safety understanding we don't have in our industry in great volume currently. And then actually the read across of how some of these technologies that are evolving will then start to impact other bits of the aviation sector as well. So you look at the digital advances needed to support drones operating and large traffic volumes of drones operating through a UTM system. You can see that has implications potentially for the role of a traditional air traffic controller. They do use various different tool sets and things, but actually you're going to get to the point where you've got an autonomous air traffic controller for crewed aircraft. And therefore, then, there are very different human factors that come into there as well. So it's not just these technologies, but how they then start to impact other bits of the existing system, that I think there's a massive amount of work to be done on. And I think that's something that, say, and going not just within civilian, but looking across broader and looking and trying to understand all that. I think that is a big piece that we do need to start looking at as a cross-domain sector.
And for expediency, I'd say that the go-to default answer is one RSC per person per vessel per airframe for whatever it's 1-to-1. That's sooner the push will be going to, should we call it swarms, because that's a term that's sort of seeping in and something, is that multi sort of vessel. Okay. And again, there's another layer of complexity there. If you are stacking just to bring them into landing at an airport or whatever, okay, I understand the environment is slowly evolving and sort of the weather conditions is that. But for instance, if you've got a maritime context, is they're potentially globally deployed, jumping from one vessel type, suddenly you're into another vessel type that's under a navigational issue, potential collision threat. How do you jump from one, which was very benign, sort of like sunny day there, to suddenly a sort of sea state stormy weather, sort of the higher sea states in bad thing? How does that cognitive load impact? How do you make your decisions? And that person's ultimately potentially responsible for the decision making. So we have to understand what that means, and therefore, in essence, create the standard to say this is how we constrain, limit, and guide the approaches to that. Because otherwise, there is that ambiguity will just creep in by default, because technology will be given as the answer, and then we're chasing the tail of servicing the technology rather than servicing the need and making sure that the technology and the process meet the need.
Yeah, and we're already kind of on the cusp of that in aviation. I'll let Paola come in a second. We're seeing now where we've got, in the drone world, people are, that's the next area they want to sort of have opening up to enable commercial opportunity, is not necessarily drastically different missions, but you've got somebody who is looking across, say, 3 rather than 1, that are doing similar things but in different places. That's the next step for us, and that's now. That's not in however many years' time. That's now. So that sort of trying to catch up with stuff, with the standards and regulation, the technology's there. People are pushing for that regulation and standard now.
I think the AI development and all the current assurance frameworks that are happening around the world, it's now the opportunity to collaborate more than ever on these things. I feel that it's the right time to align some of the AI assurance framework moving forward. I think that would be my entry point now. So what happened in the past has been already developed, but how can we align some of the AI assurance frameworks? I feel that is a good leverage to pull. Thank you.
But this is where we can give Siddhartha a bit more comfort. But again, if we can tie it back to the ODD, actually, you can say at 3, 5, 25, whatever it may be, vessels, unmanned air systems, whatever, that's fine, because actually here's the evidential traceability. So all of these become significantly interwoven, and we've got to make sure that we don't stovepipe it to one standard. That's you've got to be looking constantly at the dynamics, because it's clearly going to be challenging us at the edges. Is making sure that whatever standard we do, we're cognizant of other standards and how they may interrupt, but also the broader approach to everything, and make sure we got that holistic view rather than stovepipe.
Thank you. We are reaching the end of our allotted time. So we got a few more questions that we received from the audience. So I'll make sure that I address them to the proper speakers to maybe provide a response, or we'll take care of that after the webinar. But I want to thank you all the speakers for the insightful conversation. I think we've got quite a lot of ideas now on what we should be pushing for harmonization and standardization, that using some of the good tools that at BSI we've been developing and testing, like the flex process that Siddhartha has mentioned, we can crack on with. And also thanks all those that have joined online and have provided comments in advance, but also during the meeting. From the level of interest and participation, it feels like we should organize other deep dive sessions soon. In the meanwhile, I just want to point to you, if you want to learn more about our CAM standards, you have links on screen. We're currently running a public consultation on our PAS 1881, which focuses on operational safety cases, obviously very much focused on the on-road applications. So if you have reviewed the standard, or you want to review the standard and you have comments for us, we're very happy to receive them. And also for those of you that have already downloaded standards from our CAM suite, you will soon receive an email asking you to give some feedback on how useful these standards have been, what could be done better. So we're really interested in hearing feedback from those that are the users of these documents. So I'll conclude by thanking everyone again for your participation, and hope to see you soon again in another one of these webinars. Thank you so much. Have a nice evening. Bye bye.